Namaskar. I am Dr. Aarti Chaudhary, Assistant Professor in the Department of Ancient Indian History, Culture and Archaeology at Vasant Kanya Mahavidyalaya, Banaras Hindu University. I welcome you all in this 12-week course titled History of Science and Technology in Ancient India from Harappan Civilization to 7th century CE. Today we are going to discuss Module 9 and Lecture 3. The title of Module 9 is Mathematics and Astronomy in Ancient India, and the title of Lecture 3 is Introduction of Brahmagupta and the contribution of Brahmagupta in the field of ancient science and technology. So, let us start. At first, the learning objective of this particular lecture. So, the first learning objective is to understand Brahmagupta's introduction and use of zero and negative numbers. The second learning objective is to study quadratic equations and indeterminate equations given by Brahmagupta. And the third learning objective is to know the geometrical formula related to calculating the area and cyclic quadrilaterals. So, in this particular topic we are going to discuss the introduction, the Brahmasphuta Siddhanta. This text is written by Brahmagupta, mathematical works and theories given by Brahmagupta, and the second text Khandakhadyam, which is again written by Brahmagupta. Sri Panchavarsha Tilake Sri Vyagramukhe Nripe Shak Nripanam Panchashansayukta Shasharyateih Panchabhiratitaih Brahmasphuta Siddhanta Sajjan Ganitagya Gola with Prityaya Trisha Dvayasharn Krito Jishnu Sut Brahmagupten. Brahmagupta was a brilliant Indian mathematician and astronomer. In his literature Brahmasphuta Siddhanta, he states that he was the son of Jishnugupta, lived in the region of King Vyagramukha and composed his work at the age of 30. According to Alberoni, Brahmagupta was from Bhillamala, a town between Multan and Ahilwara. Buhler identified Bhillamala with modern Bhinmal near the northern frontier of Gujarat. He also made significant contributions to geometry, particularly with his formula for the area of a cyclic quadrilateral and advanced astronomical methods for predicting eclipses and planetary position. Revered as Ganit Chakra Chudamani, the jewel on the head of the circle of mathematicians, Brahmagupta legacy influenced later scholars across the Islamic world and Europe, shaping the foundation of modern mathematics and astronomy. Here is few points, important points regarding the Brahmasphuta Siddhanta and Khandakhadyam, which is both of the text is written by Brahmagupta. So, at first we are going to discuss about the Brahmasphuta Siddhanta. It is composed in 628 AD or CE, whatever you want to say, at the age of 30. Total 24 chapters containing 1022 verses. The 12th chapter named Ganitadhyay is devoted and to arithmetic, geometry and mensuration in 56 verses. The 18th chapter of Kutukadhyay consisting of 102 verses dealing with algebra and translated in Arabic by Muhammad al-Farazi and was titled as Al-Sindh Hind. Now, moving towards the next text, which is Khandakhadyam, composed by him at the age of 67. Total 10 chapters divided into two parts containing 194 verses. The first part of the book is Purva Khand Khadya and second part is known as Uttar Khand Khadya. It is a practical handbook for astronomical calculation, translated in Arabic by Yaqub ibn Tariq and was titled as Al-Arkand. Brahmagupta contributions. First is geocentric model. Brahmagupta described a geocentric model of the universe where the earth was considered the center of the solar system, a widely accepted view in ancient Indian astronomy. Planetary motion. He developed rules for calculating the motion of planet and accurately predicted the position of the sun, moon and planets. Eclipse predictions. Brahmagupta provided methods for predicting solar and lunar eclipses and described their periodic nature. Conjunction. He introduced methods to calculate the conjunction of planets and their relative position. Rise and set time. He developed formulas for determining the rise and set time of celestial bodies based on their positions in the sky. Sphericity of earth. Brahmagupta was one of the first to recognize and discuss the sphericity of the earth. Mathematical models. His work combined astronomy with mathematics, providing crucial algorithm and techniques that allowed for more accurate predictions in celestial mechanics. Influence on future scholars. Brahmagupta's astronomical principle significantly influenced later Islamic astronomers like Al-Biruni, Al-Khwarazmi as well as medieval European scholars. Legacy in Indian astronomy. His writing and observations laid the foundation for Indian astronomy, contributing to its advancement for centuries. So, with the introduction, we have seen the Brahmagupta contribution regarding the different calculation pattern in terms to understand the mathematical aspect as well as the astronomical aspect. Now, we are moving towards to understand the concept which is given by Brahmagupta regarding mathematics and astronomical dimension on his very important and significant text Brahmasphuta Siddhanta. The Brahmasphuta Siddhanta comprises 24 chapters and a total of 1022 verses. The detail of these chapters are as follow. The first one is Madhyamadhikara. Chapter on mean motion discusses the calculation of the mean motion of planet. Second is Spashtadhikar. Chapter on true position describes the method to determine the true motion of planets. This chapter also explains the technique and of calculating the sign, assuming the radius to be 3270 units. Kala. 3 Prashnadhikar. Chapter on 3 problem covers the 3 principal aspects of astronomy: direction, location and time, and the methods to determine them. Next is Chandra Grahanadhikar and Surya Grahanadhikar. Chapter on lunar and solar eclipses. Explain the methods of calculating lunar and solar eclipses. Next is Udayastadhikar. Chapter on rising and setting. Describe the conditions under which the moon, Mars, Mercury, Jupiter, Venus and Saturn become invisible due to proximity to the sun, setting and reappear rising when they move away. Next is Chandra Sringontyadhikar. Chapter on the crescent of the moon. Explain which horn of the crescent moon is elevated on the second day of the bright fortnight. Next is Chandra Chayadhikar. Chapter on lunar shadows. Describe how to determine shadows and visibility during the moon's rising and setting. Next is Grahatyodhikar, chapter on planetary conjunction, explain how they calculate conjunction when planets come near each other. Next chapter is Bhagrahatyodhikar, chapter on conjunction with star, detail when and how planet conjoin with star or constellations. It also includes the polar coordinates, Bhogansha and Shar of the star and a full list of constellations. Next is Tantra Pariksha Adhyay, chapter on critical examinations of system, provide a critique of earlier astronomers and their system. Next chapter is Ganita Adhyay, mathematics chapter, contain pure mathematics. From 13 to 17 chapter is include Madhyam Gityuradhyay, Sphut Gatyuradhyay, Tri Prashnodhyay, Grahanottaradhyay and Shringonuttaradhyay. They presented elaborations and question answer on the topic covered in the earlier chapters. So, this chapter is just we can see as a revision pattern of the previous chapters, which is mentioned by Brahmagupta. From 19 to 21, this is Sankuchaya Vijnana Adhyay, Chandishchutyuradhyay, Gola Adhyay, discussion on the previous chapter. Next is Yantra Adhyay, chapter on instruments, contains 57 verses and describes various types of instrument used to measure time and other astronomical quantities. Next is Mana Adhyay, chapter on units of measurement, discuss various time unit like solar, lunar and civil Savan month. And next is Sangya Adhyay, chapter on terminologies, indicate that during this period the Surya, Soma, Polish, Romak, Vasisht and Yavan Siddhant were prevalent and all of them shared many similar concepts. Now, the mathematical works and theories what we trace from the Brahmasphuta Siddhanta. Brahmagupta described 0, very important information, as an independent number and was the first to explain how 0 is used and further tried to apply 0 in arithmetic. This statement is very important in Brahmasphuta Siddhanta. Formula regarding quadrilaterals, Chaturbhuj Kon Springvatt and cyclic quadrilaterals. The formula for finding the area of the cyclic quadrilateral, which is mentioned in Brahmasphuta Siddhanta, Bhuj Yogardha Chatushtaya Bhujon Ghatat Padam Suksham. Translation is the square root of the product of 4 quantities which are formed by subtracting each side from half the sum of all sides is the area of a quadrilaterals, and the formula is here mentioned. This formula is important in terms to understand the geometrical understanding by the ancient scholars. Giving the value of the diagonal and any cyclic quadrilateral, Karanashrit Bhuj Dhatekyamo Bhayanaryoonyam Bhajitam Gunyet Yogen Bhuj Prati Bhujam Vandharyoh Karnopadam Vishame. This formula is denoted or decoded by the further scholars, also known as Ptolemy's formula, because Ptolemy also mentioned this kind of information cyclic quadrilaterals in his text. Brahmagupta gave a general formula for a rational right angle triangle with sides of the value of 2mn, m square, n square and m square plus n square, where m and n are two unequal rational numbers. From this he had derived a formula for the right angle triangle if one side different from the hypotenuse was given. Let the given side be a, then the three sides are a measurement of this structure. A detailed description of algebra is given in Kukuta Adhyay. The most remarkable one is the solution of the second order intermediate equation of this formula. For a given constant integer n, the problem is to find the value of x and y in integers satisfying the equation. Solution of this type of equation is known as Pell's equation, was found in Europe in 17th century. Without knowing their discovery in India almost 1000 years earlier, Brahmagupta he named the equation as Varga Prakriti. So, if the text is not properly described, if the text is not properly researched or studied by the scholar, then this kind of incident happen, that we do not know that the particular formula is already mentioned in Brahmagupta Brahmasphuta Siddhanta before the Pell's theory, when Pell gives this theory to the entire world in 17th century. So, these kind of similarity, this kind of study need to study this kind of text for the proper assimilation of Indian science and technology, and the proper study of this type of study can give a better understanding to just decode the study what already done by the ancient scholar, and that on the basis of that study just we can find important formulas regarding the contemporary period of which is related to maths and astronomy. So, in this context this type of important text need to be studied, need to be researched. In the context of 0, he states that when 0 is divided by negative a positive number is either 0 or expressed as a fraction with 0 as the numerator and the finite quantity as a denominator. Though his division by 0 is wrong, but was considered as a first scholar to discuss negative numbers. Now, discussion on Brahmasphuta Siddhanta and Khandakadya. The first 10 chapter deals with major astronomical topic including the mean and true motion of the planet, problems of time, space and distance, lunar and solar eclipse, the rising and setting of planets, the moon's cups and shadows and planetary conjunction. Some of these topics are further explored in chapters 13 to 17 and 19 to 21. Chapter 22 is dedicated to astronomical instrument, while chapter 12 and 18 focus on mathematics, highlighting Brahmagupta's exceptional originality and brilliance as a mathematician. Chapter 11, titled Tantrika Parikshadhyay, examination of other astronomical system, holds historical significance. Brahmagupta, confident in his abilities, critiques the view, rule and methods proposed by other astronomers, especially Aryabhat first, Sri Sen, Vishnu Chandra, Lata and Pradyumna. So, it is very important that the Brahmagupta challenged the theory which given by the scholars earlier, and this shows the pattern of the study in the contemporary period, because the pattern of questioning, the pattern to ask question, the idea to just put question to the existing thought is the basic significance to search the original theory behind any truth. So, the idea of question is very necessary in order to understand the great research or the pure research which is followed by the Brahmagupta. He asks question whatever done the earlier scholars, and then he elaborate his own principle, his own theories as well. He was also highly critical of foreign astronomical concept and elements that had found their way into Indian astronomy. He rejected the 5-year Yug system of the Vedang Jyotish and criticized the Jain belief in 2 sun and moon as well as 2 set of nakshatra. His strong criticism of Aryabhat drew attention from later scholars like Al-Biruni, who despite recognizing Brahmagupta's merits acknowledged the value of Aryabhat's system. Brahmagupta opposed Aryabhat's division of the Yug into 4 equal parts and belief in the earth's rotational motion and the idea that eclipses were caused by the shadows of the moon and earth rather than the traditional Rahu Ketu theory. This criticism can be understood in the context of Brahmagupta's adherence to the Brahma Siddhanta and the fact that he wrote the Brahmasphuta Siddhanta at the age of 30 when he was an enthusiastic supporter of the orthodox view. At the age of 67, he composed his work Khandak Khadyam, primarily based on Urdhvatric system. Unlike his earlier work, Khandak Khadya is a shorter treatise with only 8 chapters accompanied by a small appendix, Vitra Khandakadya. This work omits the mathematical chapters and focuses purely on astronomical topics such as moon's cusps, conjunction of planets, eclipses, the rising and setting of planets, and time and space. Although Brahmagupta largely reconciled with Aryabhat's system, he continued to apply his own rule in certain cases, believing they provided better and more accurate result. His work in Khandakadya includes methods for determining the instantaneous daily motion of planets, corrected equations for parallax in longitude and latitude, and better expressions for Drakarma and Valana, showing the evolution of his mathematical approach. Brahmagupta's works played a crucial role in introducing a new mathematics based astronomy to the Arab world as well. Both the Brahmasphuta Siddhanta and Khandakadya were translated into Arabic with the help of Hindu scholars by Muhammad bin Ibrahim al-Farazi circa 706 or 800 CE and Yaqub ibn Tariq 796 CE under the title Kadhind and Arkand respectively. Now the commentaries on Brahmagupta's work. These commentaries are very important to understand the whole aspect of a particular subject, because it is done by different scholars, and when different scholars are involved, then the different ideologies are involved. So, it will provide a critical study to understand a particular subject. So, it provides different aspects, different approaches to understand one subject. So, the commentary tradition is also very important in order to understand these kind of important literature. Notable Indian commentators including Prithudak Swami, Marza, Bhattotpala, Lalla, Someswar, Sridatta and Varuna wrote commentaries. Prithudak Swami commented on both the Brahmasphuta Siddhanta and Khandakadya, while the other focused primarily on Khandakadya, which suggests its greater popularity among Indian scholars. So, on the basis of this whole description, we can say this chapter highlights the profound depth and lasting impact of Brahmagupta's astronomical work, particularly the Brahmasphuta Siddhanta and Khandakadya. His intellectual evolution from a stern traditionalist to a more reconciliatory yet critical adopter of opposing ideas demonstrate his openness to refinement and pursuit of accuracy. His critiques of earlier and contemporary system, coupled with his mathematical precision, set a high standard for astronomical studies. Furthermore, his influence extended far beyond India, shaping the development of astronomy in the Islamic world and laying the groundwork for the future advancement in both Eastern and Western scientific tradition. If you want to deep study in this particular method, you can consult these references. It will help you to enhance your knowledge on this particular topic. Thank you very much for your patient listening. Namaskar.